For question 6e, we have the equation 1 over cosec theta minus 1 plus 1 over cosec theta plus 1 is equal to 2 sec x tan x. This 3 lines shows we need to prove one side equals to the other, and we're going to choose the left hand side as there's more to work with on the left hand side, which makes it easier for us. Straight away we can add the fractions together by making the denominators the same. So times the left denominator by cosec theta plus 1, and times the right denominator by cosec theta minus 1. Then you do the same to their numerators. So we're going to be left with cosec theta plus 1 over cosec theta minus 1 cosec theta plus 1, and that's adding to cosec theta minus 1 over cosec theta minus 1 cosec theta plus 1. As the denominators are the same, we can bring everything together. So now we're going to have cosec theta plus 1 plus cosec theta minus 1 all over cosec theta minus 1 cosec theta plus 1. The 1's cancel out at the top, and these two add to give 2 cosec theta, and at the bottom we'll expand the brackets to give us cosec squared theta plus cosec theta minus cosec theta minus 1. These two cancel out to give us 2 cosec theta over cosec squared theta minus 1. We know the identity of cot squared theta equals to cosec squared theta minus 1, so we can replace this cosec theta squared minus 1 with cot squared theta. So that gives us 2 cosec theta over cot squared theta. And now what we can do is we can rewrite cot squared theta as cos squared theta over sine squared theta, as that's our identity. So now we're going to be left with 2 cosec theta over cos squared theta over sine squared theta. That's the same as writing 2 cosec theta divided by cos squared theta over sine squared theta, and that's the same as writing 2 cosec theta times by the reverse, which is sine squared theta, over cos squared theta. Cos squared theta is the same as 1 over sine theta, so that leaves us with 2 over sine theta times by sine theta times by sine theta over cos squared theta. The reason I wrote sine theta times by sine theta is that it's the same as sine squared theta. The sine thetas will now cancel out, and that leaves us with 2 sine theta over cos squared theta. Now what did they want? They wanted 2 sec x tan x, 2 sec x tan x. So what we can do now is recognize what these are the same as. Sec x is 1 over cos x, tan x is sin x over cos x. Can we bring out these two expressions from this? Yes, we can. We can bring out 1 over cos x by doing that, and that would leave us with sin x, sin theta. I keep forgetting. Sin theta over cos theta now, as you've taken out cos theta. Sin theta over cos theta. That's the same as tan theta. So that's tan theta. And that's the same as, sorry, 1 second. 1 over cos theta is the same as sec theta. And sin theta over cos theta is the same as tan theta. And that's what they wanted. 2 tan theta, tan theta. 2 tan theta, sec theta. And we've proven that.